And sure. Okay. So aligning emerging technologies to future use cases in space. India's space forays have resulted in significant technological advancements, facilitating growth in numerous sectors like defense, communication, surveillance, navigation, agriculture, weather forecast, data analysis hub, and logistics. A paradigm shift in thinking and foresight is required to ensure that companies are able to create valuable interventions required for future use cases, both in military and civil domain. This may be best served if the entrepreneurs are guided to develop products with insights that may be beyond their present of expertise. So right now, our moderator, Lieutenant General G.A.V. Reddy, would like to introduce to the panelists, sir, and we would also welcome His Excellency Ambassador Freddy Svane, who's doing a namaste, sir, from Denmark, who's ambassador to India from Denmark. Thank you, sir. I will hand over the mic to you, sir, now. Thank you.
Good afternoon, ladies and gentlemen. I am Lieutenant General Reddy, former Director General of Defense Intelligence Agency and the Deputy Chief of Integrated Defense Staff. Presently, I am the Chief Strategic Advisor of Synergia Strategic Think Tank at Bangalore. Now, the topic for the noon is aligning emerging technologies to future use cases in space domain. Why we thought of choosing this topic to be spoken about and discussed and debated in a forum like this is that, of course, space as the central theme, we are also going to talk of other domains as well, where we need to develop emerging technologies for the future use cases. Well, before I speak anything about the topic per se, let me have the privilege of introducing the eminent panelists with us this noon. Ambassador Freddy Svane from Denmark is the Ambassador Denmark to India. Lieutenant General PJS Pannu, PVSM, AVSM, VSM, former Deputy Chief of IDS India. Mr. Manoj Parmar, Chief Executive Officer of Bosch AI Shield. Mr. Sunil Indurti, Director, Azista Aerospace. I think you can rise. He is right behind me. Then we have two young CEO CTOs. One is Ms. Sri Supranai, CEO Andurats, and Mr. Nirvik Chaudhary, CTO Andurats. Right. As a moderator, let me give a little context of this topic. I look at it from the session that at the end of the session, I must have three answers. Firstly, how to identify the future use cases, particularly in space domain. Second question, which I would be wanting to find out for myself, is that having identified the future use cases in space domain, having traced the contours of future use cases, how to align these emerging technologies to the future use cases. And third and most important question to be answered for myself is, what do we do to achieve this end state? And how do we guide our entrepreneurs to develop technology and products to become the use cases in the future scenarios? Well, we all understand there is a need to leverage the emerging technologies for numerous reasons, for enabling new capabilities, for advancing space exploration or utilization, and also to drive the new space technologies, both for civil as well as military applications. But how do we leverage the space industry? There are numerous challenges which the eminent panelists would be talking about. I'm just giving a hint of those which will be talked about. First is to lower the barriers in the space industry and create the ecosystem. Next is to increase the access to the cutting edge technologies, particularly access to the entrepreneurs. And finally, drive the commercial opportunities in the space domain. That is how we must leverage the space industry. Now, all this will form part of the transformative revolution in the space. As Synergia think tank, we are making an attempt to bridge this gap between the technology developer with the user, particularly in military domain, because many of us in Synergia are from the military background. We are taking these entrepreneurs, startup CEOs and MSMEs to the users, the armed forces, and bridging this gap of understanding the user's requirement and specifically developing the tailor-made products or technologies to meet the requirements. Well, all this and more would be spoken by the panelists with us this noon. To begin with, I would request General Pannu to come up, share his thoughts, giving an overview of the startup ecosystem, including the space domain, and outline the methodology of enabling these startups to be successful in this endeavor of our nation to become self-reliance. Over to General Pannu.
Thank you, General Reddy. Good afternoon, ladies and gentlemen. The subject is interesting and very, very vast. And largely, a couple of years back, we would say that's a very new subject, but not now, for the reason that number of space enthusiasts, number of entrepreneurs, number of business houses which have started taking interest in the space sector is increasing by the day. And today, since morning, we have been hearing the figures in billions of dollars that we are touching and more multiples of that in the future. And also how number of startups are multiplying ever since the privatization of space has been announced in our country. And I think this is also true for the entire world. The reason is that space was always seen as a very distant field for ordinary citizen. As if it was not our business, it is somebody else's business. And those people who are doing an activity in space are people who we don't know and we can't understand. They're different type of people. And more so, it was true for India because ISRO was seen to be the only one understanding the space and doing certain activities which we only read in the newspapers and saw in later on in the radios and heard in radios and televisions. But over a period of time, one understands that space is now in every form, from the industrial application to use cases for agriculture, for marine life, for terrestrial, non-terrestrial, for subterranean, for subsurface, to the surface of Earth and oceans. And it goes right above us into the aerospace and space, virtual space and the real space. And now we are talking about the new space. The technology is also shifting so rapidly that the traditional space applications are also being challenged, and new space technologies are coming up which makes our ecosystem not only in the space but also on ground smarter. As we grow and get more networked, you realize that in the military, how it is known is that space is the fourth frontier. The fifth frontier is the cyber. And now there is no dividing line between cyber and space, because all the activity which is undertaken, cyber activity on ground, is also being undertaken in the space. So as a result, the SDR norms are being utilized elsewhere. So when we go from people we didn't know, that is the industry or the government agencies which are far detached from us, and we could not meet them, and all of a sudden you find that there is an ecosystem and people find that how can I be in space? Or if I want to do business, how can I do business in space? If I have technology, then how can it be in space? But the way such events are coming up, you realize that more and more youngsters are investing, because it was very dreamy initially. Then they found that that dream can be realized because the education is providing them that kind of an education awareness. And the space industry per se is making a huge business case. But as a result, even today we are stuck in some point that a lot of people who dream and a lot of people who have a product in mind, they have a use case in mind, still they are not very sure how to connect it and make a business out of it. They don't understand what is the scale of business. They don't understand where is the value chain in this. And they don't understand who to contact for regulations, for policy, and how the other technologies can be intermeshed in understanding how the whole value chain will unfold into a larger industrial complex. So here we are today in this session talking about everything can have space in it, and space can be everywhere. So space is going to be omnipresent, whether it is on the earth or it is in the planetary understanding of it, or even underwater. It is ubiquitous, it is omnipresent, and it will always remain so. So when we are talking about space, we have, of course, two youngsters sitting next to me. They are amazing when they start talking about the dream. And the dream is not just a dream. The dream is they have a product in mind. When they have a product in mind, they understand the threats. So therefore, when we look at space, we look at where we are as India. What are the opportunities available to us in space? And as far as military is concerned, we also are very, very conscious of the fact there are threats from the space and we need to defend ourselves. So therefore, we can use space from the military aspect of security and going down to full trade and commerce and activity, which makes it billions and billions of dollars of use case. So as a result, there are lot of players which are looking for incubators, accelerators. They are looking for programs which are hand-holding programs. They are looking for programs such as IDEX where they can put their idea. But there is a large confusion about who should I go and talk to? Who will give me the money? Because a lot of investors would not want to invest in something that they don't understand, or they don't understand whether they will break even or not. In the morning, Dr. Goenka was talking about the valley of death, that the number of startups have actually gone into the valley of death. It means they haven't folded up and they have come out of it being successful. He was also talking about making break even. And the moment you cross that barrier, you find that there are certain role models which have come up, and all those, some of them are of course partners in this India Space Congress. Some of them are role models of success. But I think largely we also need to understand, why does a startup fold up? What was the problem in the initial thought process? Where was the problem in converting the idea into a product which was not sellable? Or even if there was a product, what was it that they could not convert that product into something which is marketable? So I suppose when you're talking about Synergia Foundation, they are sitting where the entire technology and ecosystem comes together. There's a huge amount of networking which happens. So rather than only having a networking which is disorganized, I think there is a culture here that we are trying to create, that we build a systematic approach to getting the startups and getting the incubators into our system and putting them through a process. So, for example, I have a committee which is on defense. So that is a defense committee on space, where we will bring all those aspirants of the industry or the startups who are wanting to invest in defense space. So they will come in and we will tell them where they would go. So number of activities have been planned even during this forthcoming next 2 days, a couple of sessions programmed for it. So we look forward to listening to the excellency, how the space cooperation will happen, because space is literally a global common. And not every investment has to be made by every country wholesomely into the space. I think no country will be able to spend so much of budget on the space and they would not realize it because they are only a small piece of the land. So largely the value chain will come up when there are a number of friendly countries that come together to realize the whole value chain, and I think that is what we need the international cooperation as far as the space sector is concerned. And similarly, when you talk about the cyber, there are threats, and we need to make sure that there is a cyber shield of the space which we develop. And at some point, we should be able to get a cyber seal, and not only the shield. It means that in everything that we do is owned by us and works for us. And when you talk about the applications of AI and you talk about the failure, so I would just conclude by saying there are 3 pillars of success in technology: power, materials, and electronics. And if you look after power, materials, and electronics, all your other applications, which today in the morning was spoken, that if you want to get into the value chain, you don't get into manufacturing, but go into applications of it. And I suppose once you go into the applications of it, you will be introduced into the space domain to make gradual progress and contribute to the other streams. Thank you. Thank you.
I thank General Pannu for sharing his thoughts on space as the 4th frontier, and he said space is going to be omnipresent, of course, without any doubts. Everybody agrees on that. And also he's categorically said what the entrepreneurs would be looking for, whom to approach, how to generate funding. These are the issues that we are also in Synergia being encountered with day in, day out. They don't know, in a vast ocean of systems and organizations, where to go and approach and pitch their technology or the product. Also, he said that building a culture of facilitation for defense industries, that's what I think most of the think tanks are also engaged in, like we at Synergia are also focusing on. And I once again thank him for being very specific, and within a short time he has made the pitch. Now I have the privilege to invite Ambassador Freddy Svane of Denmark. He will be speaking about India as a superpower in space technology with enduring and low-cost technology provider. Over to the Ambassador.
Thank you. I thought it was a very innovative kind of headline of my intervention. You liked it? India being a superpower in space? Yeah, I guess so, huh? Before giving my lecture or address, I'll share 2 things with you. And I don't know how many of you have, on a personal note, managed to get something to the international or to space and get it back. No, no. I did, and I tell you, it took a lot of efforts. And I just give you the example because I know the young entrepreneurs, they face so tremendous amount of challenges every day. When I was in Japan as ambassador, I went to JAXA, which is the ISRO of Japan. And we were celebrating 150 years of diplomatic ties. As we do in diplomacy, we had to develop a special pen, a badge which was showcasing the colors of our flag. Denmark and Japan, we share white and red. So we had a special pen, and I had a number engraved. So I went to JAXA and said, to celebrate our 150 years of diplomatic ties, I want this pen to be sent to the International Space Station. They all said, impossible. I said, impossible is possible for me. So I got hold of one of the Japanese astronauts and said, I know you have 5 kilograms of personal things that you could bring to the International Space Station. This is less than 1 gram. Bring it up. And he brought it up. But it took almost a year to get NASA and other important institutions to verify that this pen and the metal being used to produce the pen was not lethal or making the space station exploding. But it got up. And I have a photo, and I got the pen back, and I checked the numbers, so it was not a fake thing. So it can happen, but to do that takes a lot of effort. And I don't dare thinking of how much of effort it takes for the young entrepreneurs, and you have so many in India, to get to a level where you can bring something to space, which will be of importance to all of them, all of us. This pen was perhaps for diplomacy good, but for the humanity, not so good, if I may say so. Secondly, I have a dream. I've been serving as ambassador to India 10 years. I'm here on my 11th year. 11th year. Many of you were not even born when I came back in 2010. You were, of course. Maybe, yeah, we don't know. Anyhow, and I have been witnessing your honorable prime ministers, and especially Prime Minister Narendra Modi, launching so many missions and special schemes and so forth. So my hope is that at one of the upcoming Independent Days, your honorable Prime Minister will not only launch green hydrogen schemes or Jal Jeevan missions and all that, but he will in fact launch a special mission for space. Why? It's not to flatter you, but India is a kind of treasury for all of us when it comes to develop new technologies, emerging technologies, where we in a peaceful but also innovative way can utilize the space. And space, of course, you said, Pannu, you said, ideally, it belongs to all of us. Yes. But when we look into how we have treated our own planet, where we are still in control to some extent, except for the heat here in Delhi, but can we do something which is very different from what we have done here on the planet when we are moving to the space? I have my doubts, really. So therefore, it's so important, two things, that the countries, nations sharing the same values, like we, Denmark and India, we do, that we take initiatives really to work together and secure that we can utilize whatever resource that we can get from the space for a peaceful, sustainable. We also need to think about sustainability when it comes to space in such a way that will serve the benefits of humanity. We can talk about water, we can talk about climate change and all that kind of stuff, how to utilize the resources of the planet in a far better way. That will come by its own. But the entrepreneurs of India, you might not have the resources, you might not have the labs, you might not have too much to do with, but in fact, you are doing things, you are breaking boundaries that we in our, let's say, pampered world, we don't dare thinking about. And when I look into my top university when it comes to technology, the Technological University of Denmark, they have a space department, very advanced, I would say, not in all fields, of course, but many of the researchers are from other countries. So I hope to see many more from India coming over and helping us in developing space. We are very good in micro satellites and nano satellites and all that. And of course, we can't talk about the planet, we can't talk about the space without talking how do we defend ourselves against all kinds of evils. And evils can be defined by many and in different ways. But space offers so many of opportunities, but also offers a lot of challenges. And if countries like ours will not work together, then we will be facing an almost unprecedented level of warfare. So therefore, we also need to develop that kind of system to defend ourselves, not to attack others, and that's so important. When I look into Israel, I'm so impressed. And I still recall when we heard about the moon vehicle, people were saying, that's not possible. India is about Yugat, and we'll find a little bit here, there, and everywhere, and then we send it up, and hopefully it will land somewhere. But when people realize that you, in fact, were the first nation, you were the first nation to put that vehicle on the dark side of the moon. That raised not only the proudness, like me serving here in India, but also really contributed largely to the success story, growth success of India. And there's no future for us as humanity without space. But my message to you, and therefore you have to take care of all your youngsters. All your youngsters. You're a youngster. But you're not. Oh, okay. Not even young in mind, but then that's okay. That's how it is. But you have to take care of these youngsters, because whatever they can develop is important to all of us. You are talking about all your unicorns, and I hope one day we'll talk about space corns, because that's better. Unicorns is for the life here on this planet, but beyond that, we need you. And I do hope, and it's not only a personal request to your Honorable Prime Minister, but I hope by promoting a mission for space that there will be far more concrete, tangible, focused support for these youngsters, the entrepreneurs, who will not only start up, but also scale up and make space part of the answer to all the challenges that we are facing. So therefore, the title that I just picked out of my old brain was not in vain, because I think, I believe, I hope, I expect that India will be a superpower when it comes to space. You have all the needed things to do that, but you have to combine it, and you have to have a special mission for that. So from Make in India, Digital India, I always say, now it's time to make India great, green, and also in space. Dhanyavad. Thank you very much. You didn't like it? I like it. Ah, that's good. Sorry, I'm a little bit super accent.
Thank you, Your Excellency. I think he spoke of his dream of seeing India as the superpower of space. And he also has been magnanimous in saying India will be the treasury for the globe in space domain. But I want to ask General Pannu about a statement that Ambassador has made, that Indian entrepreneurs breaking barriers despite limited or very little resources and leading the world in the space of in the world space domain. Is it feasible that Indian entrepreneurs can lead the world in the space domain despite the limited resources that they have? If feasible, then what needs to be done by the government and other regulatory systems to facilitate that? Your comments, sir.
Don't make me unhappy.
Ambassador, you said everything that was music to India, and I think together we can make orchestra. So it's not clutter when we are doing it together. We do it in a very nice way that makes music. But what is important here is that one is that in last 5 years, we have seen a lot changing. In last 5 years, as far as defense is concerned, we raised the Defense Space Agency, then we raised Defense Cyber Agency. After that, we moved towards privatization, and the government of India not only came out with the space policy, but also raised something called InSpace, which is not only promotional, it also facilitates. And largely today, in last 5 years that I'm talking about, we have 200 startups. And these startups every day are coming up with something or the other. Either they have a technological demonstration being proven successfully, or they're getting a contract. Also, in the same room just before our session, we were hearing it from the Australians how the Indian startups are collaborating with the Australian together, that they are being invited there for joint ventures. So we always thought that the world will come to India and handhold India for joint ventures. What has happened is in the last 5 years, it is happening the other way also, that we are going out for joint ventures where the others are looking. The Western world is also looking at India for a joint venture. The third thing is that in the morning it was being spoken that don't look at India as a market. India is a manufacturer, and India is looking at the rest of the world as a market. So if that is going to happen through the joint ventures, which is more of a trailer and an indicator, that our startups would not only start up in India, but they would also start the ecosystem outside. I think that is where we would have actually crossed the carbon line of space activity in business. The next thing is that the number of entrepreneurs which were shy of space have realized that space does not mean that you have to manufacture in space, you have to manufacture it here. And you have to manufacture with the materials, you have to manufacture with the technology, and you have to manufacture with engineers and the skill sets which are available here in India. Or if they are not available in India, at least the internet. Today we have something called the National Knowledge Network. In the National Knowledge Network, if the institutions are members of that, they can exchange so much of knowledge. And I didn't know National Knowledge Network till the time I actually visited them about 5 years back. And I realized that the kind of knowledge which is actually flowing within India and outside India, because National Knowledge Network has its members even outside. So the huge amount of research which is moving through these networks is humongous. And today we have number of military institutions which are, because I was instrumental in it. So I am very happy that, even they are contributing and being part of National Knowledge Network. So I think we have the ecosystem. We have grown wings. We just need a little bit of favorable wind and take off. Thank you.
Thank you. I think it's very assuring, and he has not just delineated the various actions being taken by the government and other organizations, but also the huge potential of collaborations and the corresponding commercial benefits. Now, I request Mr. Manoj Parmar, CEO Bosch AI Shield, to share his thoughts. He is going to speak about space domain, the vulnerabilities, the challenges, and the methodology of securing and addressing these vulnerabilities. Over to Mr. Manoj Parmar.
Thank you for the warm introduction, and thank you, panel members. You spoke a lot, and now I have a very big shoes to fill in. So I'm going to change my script. I'm going to start with a story, and it's going to be the Christopher Nolan's Interstellar story, which will move across the time. So keep up with me. I'm going to talk about 2007. I'm going to talk about 2023. I'm going to talk about 2047, and all the way back to the 1968. We are going to move through this entire storyline, and I'm going to give you the very different kind of a perspective which is there. So let me start with 2007. 2007, I was in the college, and my professor asked me that, do you know what was the toughest thing in the first Apollo mission, man mission? The scientists were not worried about the humans because they have developed a lot of technology. They were worried about the Apollo guidance computer. They were sending the first time the ICs into the space. The compute they were most worried about. And you know what was the biggest problems? General Pannu just touched about the power related aspects. PME, as he told about, right? A single bit flip in that particular computer can make the entire Apollo mission fail. Single point of failures, which was there. And at that point of time, my professor told me a very interesting thing, is that if humans really have to fulfill the space mission, the frontier will start with the compute. Because till 2007, the connectivity in the satellite systems, the communications, the sensors, the data, everything was there. But compute was never on board. Compute was always off board. All of the data, all of the satellite link sends tons and tons of data onto the ground. And that's a limiting factor. That was a single point of failure. This is 2007. I'm going back to 1968 now. Apollo's control room. Guidance control. These are the two scientists who are talking. That what will really have an impact onto this entire mission. And one of the scientists says that we have not built a redundancy in the system. Reliability, fault-tolerant computing was not there. And they were so much worried that what will happen to the ICs that they ended up creating a redundant analog computer. Now, Apollo 13 was not the first catastrophe. It was the catastrophe with the humans on board, but it already happened. So far, till 1968, everything was an analog for the satellite systems, 1968. So we started looking for the first thing. So somebody says we have a problem of redundancy. Somebody other says power consumption can spike and it can heat up. Third problem was the thermal, which are there, thermal runaways that can happen. And all of these problems were discussed so much, and they thought that we will be able to solve it. Next mission. Entire Apollo program is finished. And finished long time back. We have still not solved that problem. 1968 onwards, the problem of the compute which started, it still remains today. It is only in the 2023, that is the last year, when the Japanese Space Agency put a first small data compute in the ISS. Because now today, entire science to fast forward, you need a compute power. And this is the first time happened. 1968 to 2023. This many years we took to make the compute ready, onboard compute ready. And this tells that why this compute was really, really essential. Because without compute, nothing is working today. We talk about AI, we talk about the mission planning, everything is powered by computers. And I'm not talking about normal computers. We need a very different kind of computers which are there. And these are the kind of computers that just made realization in 2023. Now with this story's backdrop, I'm going to now take you into 2047, which is there. I request everyone to close their eyes and imagine a scenario with me, which is there. So please cooperate. Close your eyes and imagine that you are in the 2047. I have transposed you all the way down to 2047. All of you now no longer have your mobile. All of you have your personal satellite. Imagine what you can do. 2047, every one of you have your personal satellites. These are the nano satellites. Imagine the power of that. We did not imagine that in India we'll have so much of a proliferation of a mobile, right? We do have now. What will happen within a personal satellites? Yes, the personal antennas, but you don't need an antennas, because today the miniature antennas which actually the powered by mobile, right? It came from the space tech, quadruple antennas which are there. So imagine the kind of use cases that we'll have. The first use case that we will have is interplanetary AI systems. Personal assistant fully connected across the world, doing a trade, everything on behalf of you. The mobile has revolutionized, the satellite is going to revolutionize even further. This is the one thing, interplanetary AI systems we are talking about. Obviously, this will need also a compute, heavy compute, which is there. So this is the one interesting use case that I'm going to tell you, is the interplanetary AI system with the personal satellites as a thing. And this might look like a dream, but we can dream bold today. Still 2047 is far away for us. No, you are too young. So this is the yes. If you have the personal satellites, we can do tackle a lot of planetary issues like climate changes, the healthcare, and things like this. This is going to be the first time that we will get a capability. And I'm just not telling, I have the real data point today to hypothesize that. The weather forecasting which we are able to do today is thanks to the satellite which we have launched. It's thanks to a lot of ground stations which are there. The Denmark has one of the green set kind of things which actually powers the lot of European weather systems which are there. So these are there. We just have to imagine. I am an entrepreneur. My job is to imagine. My job is to generate that particular imagination and ideas, and then take that ideas to really to the ground level and start building. And the journey is not going to be the easy. And this is the point that I want to take from 1968 to 2023. It took this many years to make a single data compute to send to the ISS, which is there. Idea existed before that. Personal computer came in 1990s, became ubiquitous. And still it took 23 years because General Pannu just hinted us in a way that idea is there. You need to build a product. You need to make it to the, the necessary standards to meet it. Like MS said about the pin, right? A simple pin took in 1 year. It had nothing. So imagine what kind of situations that we are dealing with. So we need to imagine. We need to imagine in a bold way, which is the case. And this is from the all civilian point of view that I have talked about. Now, when every personal satellite that you have, and this is all interconnected and doing in a lot of transactions, imagine the good that you can do. But at the same time, imagine somebody comes within with a malicious intent. We will also need to secure all of those things. Because if we will not secure them, then nobody will trust. And if nobody will trust, nobody will use it. And if nobody will use it, entrepreneurs like us are never going to reach a break even, which is there. So we need to also ensure that when we build the technologies and we take it to that level, we also need a security. I'll just give you some of the examples, which is there. And these are the real examples coming to the mind. European Space Agency's Hera mission, which is there, which is designed to do a lot of AI integration inside it, and it can be used for many other purposes. And it is a brilliant move. We also talked about the Chandrayaan, and then there is a Mars rover there. Nobody was manually, driving them. How did that happen? They were all autonomous. We talk about the autonomous cars here, but we are much more successful to send the autonomous vehicles across the different planet. These are the kind of challenges and opportunities both we have. And when you come to the defense side of the same equations, it's very, let's say, an interesting story. Space is a net new frontier. First time it's not in a zero-sum game. On a land, either it is my land or your land. Airspace, either my space or your airspace, which is there. Water, a similar thing. Space is infinite. Obviously, the near space is still in a contagion zone, but rest of the space is infinite. And when we will start utilizing the space for the defense purposes, as I just hinted you, with a lot of interplanetary AI systems or the satellites and everything that we'll need to protect them, we have to protect from the three different point of view. One is to protect from economic interest point of view because it's a strategic asset. Two, utilize the space as in a means, as in a detraction. Okay, fine. Sure.
Sorry, interrupting. I'm looking for my personal satellite.
Yes, sir.
Sorry, I have to leave, but
Okay.
big value and ideas and innovation. All the best. Oh, is that the my satellite? Yes. So this is
That you have to send it to the space agency now.
You have to do the same thing that you did with the pen.
Another 1 year project.
Thank you. Don't look so disappointed. Thank you very much indeed.
will just. Yes. So, as I said, one is I was there on the very specific space that we will need to also protect this entire space thing from the point of view of national security, economic growth, and adversarial use of this thing. And just give you the couple of examples. The incidents are already started happening with respect to the space. There are a lot of space recon missions are being spoofed today, which is there, and there are already the evidence for that. That means all of the investment which has been done to get the early warning systems, observations, and all of this is no longer going to be trustworthy if there is not additional layer is added in terms of a verification. This is already has happened, which is there. Also, when we go into this kind of in a security mode, we need to also ensure that we have the necessary protocols which are there, which is for the communication is there, for data is also there, that we are encrypting it, but for compute we don't have. And for the compute related aspect with respect to the AI, we are still far away, which is there. And we need to really work on all of these aspects to go forward. For an example, NASA's Mars rover that I just talked about had lot of issues with the image recognition. We have seen a lot of times in the newspaper that the Mars rover detected something which looks like a human made, but it is not a human made, which is there. So these are already the incidents with an AI which is already happening, which is misleading in some cases. And if you give the full control over it, it will do certain different kind of recognition on top of that. Another issue that we are started seeing is the space debris. This is like weaponization of a space debris. If I actually can change the trajectory of any of the dead debris, or if you can just put them in a wrong way, it can destroy the existing satellites. I don't have to send a weapon from here. I just have to ensure that the space debris collides with one of the working satellite and it is taken out, which is there. We have already started seeing some of the predictive maintenance in the space, where especially with the ISS and its own missions, that they were not so much reliable. So again, what is happening is that with the real-time monitoring and observation, which requires a lot of compute, we are yet not ready for the space. And this is one of the frontiers of the technology that if we can push further together in a more secure way, will open up much more use cases and applications that we will discuss further as well. And my only hope here is that we will not make the kind of mistakes that we have made it in the past. And I just want to leave with the 3 specific things as an entrepreneur. First is that dream and dream big, which is there. Don't shy away. We can do it. That's the first thing. We don't need almost 50 years to send a data compute to the space now. We can do it much faster than that. Second, whichever technology that you are developing, develop with the end of that particular, let's say, the end application in the mind. If you are developing technology, don't develop just for the sake of developing, because developing a technology requires resources, a money and a talent and a time, and we don't have that much. So have an end application in the mind, and if these end applications are the killer applications, if you can imagine it and if you can demonstrate, the resources will follow. And the third, everything that you are developing today, ensure that the security is at the forefront of it, because today's world, trust is very scarce, and once lost or once broken, it's very difficult to get it back. And with technology, how much ever that we love, how much ever that we preach, in the back of our mind, the evil side of technology always lingers. And if I am developing an application, I need to always take care of that lingering dark side of a technology by securing it. And all of the 3 things, if we can do it appropriately, space is big enough not only for one Earth, but for the planets together. That's the imagination. With that, we can grow. Thank you.
Thank you, Mr. Manoj. I think he's brought on by specifically giving last 3 key takeaways, 3 takeaways that he mentioned. But before that, he beautifully delineated on the issue of the challenges and the opportunities separately. as well as the challenges with the malicious intent in space domain. Thank you. And now I have the privilege to call upon the young CEO Andurag's Miss Sri Supriya Supranai. I hope I pronounced your name correct. She will speak on space planes for future missions. Over to you.
First of all, good evening to all the visionary entrepreneurs and space innovators gathered here today. Sorry, sir? 23? Yes. Firstly, I'd like to thank our patriots, Pannu sir and Reddy sir, who have given me this esteemed opportunity to share my views. Pick anyone in the world, in any country, in any industry, and ask them, where do they see themselves or their industry or the future generations in the upcoming century? They will tell various advancements from cloning the people to mining in asteroids. But one common thread that will come out of all of them is they'll see their future generations and they will see their technology developing in space. So space is not a single industry, but it's an accumulation of advancement of whole human civilization. And that is what inspires us to contribute to this domain. And this future consists of bringing sci-fi to reality with various aspects like space tourism, in-space manufacturing, space warfare, interplanetary civilizations, and many, many more. And in this journey towards this transformation, we, India, are moving forward with various missions ranging from space station, Gaganyaan, Chandrayaan, and whatnot, so many. But to fuel this journey of future, it is important to determine how today's technology should be so that it paves the way for our missions. That is the exact question I believe sir has asked and would like to get answer for. What should the technology be today so that it leads us towards that? And in my view, today's technology should be dual use, versatile, sustainable, reusable, and affordable. Yes, we know all of this. We know that innovation has to be sustainable and affordable. And every idea that comes with a spark of creativity to solve one such challenge or to bring up one such element. But then starts the real challenge. Where exactly to draw the line? At what point to ensure if this is feasible in the market, if this is affordable enough, or if this is versatile enough. And for the solution, I believe for that is collaboration. Collaboration and the great minds and all the expertise giving in their inputs will make the idea and the product more robust and feasible into this market. And with all of this together, we are crafting a future where space is not just a destination, but a realm of endless possibilities. And by collaborating this ecosystem, rigorous innovation, testing, supportive policies, and receptive market, I believe that we can bring all of the expected, all of the sci-fi we imagine, and all of the imaginations to reality in space tomorrow and also today. Thank you.
Thank you, Ms. Sri. We've been very cryptic, but I like you saying that it has to be sustainable and affordable technology and the need to collaborate to make it with the exploration or the utilization of the endless opportunities in space domain. Now I have with us Mr. Sunil Indurti. He is the director of Azista Aerospace. He will talk about the use cases development through advances in satellites, payload, sensors, and data processing. Over to Mr. Sunil.
Thank you, sir. So it's been quite hot this summer, right? Particularly in Delhi, you talk of 50 degrees Celsius. So talking of future use cases, I can think of, you could just look around you and you'll find problems that you can solve using spaceborne systems. 10 years ago, we didn't have some of these commercially available thermal imaging satellites, but today you have these satellites which can actually map heat islands in densely populated cities, let's say such as Delhi. So using these thermal imaging sensors, you can identify, let's say, buildings that need better insulation so that they are more effectively cooled inside. You could also identify very large concrete areas where probably you could have a few more trees that can actually cool down because what has been found is that these certain concrete jungles, within the city, they are about 5 to 6 degrees Celsius or 7 degrees Celsius higher than the surrounding areas where there are a lot of trees. So problems which you didn't have about 20 years ago or 10 years ago, you have them coming now, and you will continue to have them in the future. So advances in technology like this can be applied to problems that you see around you. Let's say in India, there are some very India-specific problems or issues that can be solved, and I'm sure eventually they can be exported to other countries globally as well. Because urban heat islands is not just a problem in India; it's even a problem in Europe, right, during summers. So this is just one use case in the civilian space. You could also talk of groundwater pollution, right? Plastics. You can monitor and track plastics using spaceborne imaging sensors. Could identify some stable isotopes that can be tracked. You can understand how they are moving, what is the source, how they are flowing. This can help in, again, planning filtration mechanisms or understanding where the source of the problem is, right? And you could even use spaceborne imaging sensors to solve supply chain issues. Let's say in the case of iron ore or some very volatile supply chain products such as metals, right? Some rare metals that are very volatile in, when you trade, let's say in nickel or cobalt, that are predominantly used in the electronic battery manufacturing industry. So those can also be tracked, let's say from if China is probably about 70% or 80% of all the lithium in the world is processed in China, so is nickel and cobalt. So they are the ones, let's say, holding up or controlling most of all the inventory and supply chain. So if you are able to identify how much of material is stuck at a port using some of these sensors, right, you can basically predict what is going to happen in the next 3 months. Right? That information is more useful for the manufacturers and probably stock traders as well, because stock traders, you can only receive information after the quarterly results, but such predictive information about supply chains of various companies can help you make better decisions faster. So these are just some of the use cases in the civilian space. If you talk of even some of the new sensors such as signal intelligence or ELINT, right, they were not commercially available 10 years ago. You could use them now to track these ships that turn off their AIS transponders, right? Ships that are basically doing some illegal fishing in restricted areas that turn off their transponders. So this is something that you could do using the commercially available signal intelligence and ELINT data that is currently available today. So as time goes by, new sensors will be available, new problems are available. You just have to look around and find ways to offer new solutions. So I think as some of the speakers before me told, particularly about applications, right? Hardware is something which is undergoing in a lot of innovation. There are a lot of good things happening in the hardware area, but applications is one area where you could have a low entry barrier, easier to create value, right, for the people around you. So it's and which actually create a lot of impact as well, and that's where a lot of value is there to be unlocked as well. So I think that's something I'd like to say in the civilian space. If you talk of the defense sector as well, again, the users, right, they keep talking about having from tasking to basically on the table, they want to have the imagery as quickly as possible, right? So how much imagery and how quickly you're able to get, and what are the insights you can get, right? So these things can be improved, right, with some of the new processors, right, that are available. Some GPUs that can actually be flown on your satellites, where you continuously image, right, let's say for 30 minutes or 40 minutes, and you don't necessarily download all the data. The payload is always turned on. The payload is constantly processing. You say edge computing, but edge computing in currently the satellites that are currently running edge computing, they run this on certain images, let's say for 5 minutes or 2 minutes or so. But here we are talking about the payload being turned on continuously for tens of minutes, and the edge computing the payload is continuously turned on, and it is always processing the images that are being taken by the payload, and it is basically rejecting or accepting some of those tiles of imagery, right, that are identified by the AI payload. So for instance, if you're looking for ships in the middle of the ocean, and if you're scanning for about half an hour, you don't find ships at all for, let's say, for the first 10 minutes, you don't download that imagery, right? For the remaining 20 minutes, you identify about 500 odd ships, you get that data, right? So you train the models on ground and then upload onto your satellite and be able to run using some very powerful GPUs. This is possible, right? So again, there are some hardware changes that are happening that can impact the applications in the defense sector as well. So overall, I mean, space, you have a lot of changes happening in the satellite hardware, as well as new payloads are coming up, right? And as well as new problems are coming up in the civilian sector. There are a lot more satellites that are being flown. So a lot more commercial satellites being flown, let's say compared to 20 years ago or 10 years ago, you have a lot more high resolution imaging data available today. What that means for us is that the data is cheaper compared to 10 years ago. That means if it's cheaper, it opens up more commercial applications, which means new opportunities are again unlocked. So it's about staying track of what changes are happening, what new sensors are available, right, in the space ecosystem, and then how you can solve problems. I think if we can take this approach, I'm sure you can constantly work to create value, right? You can look forward for the next 5 years, what all applications are possible, and you could start already working on them. Yeah, thanks.
Thank you, Mr. Sunil. I think he has beautifully listed out numerous day-to-day life use cases, and particularly both for civil as well as military domain applications. Now we have the youngest CTO, Mr. Nirvik Chowdhury, again from Mandurax, and he is going to talk about future space warfare, including hypersonic warfare. And he is going to quickly rattle it out in next 5 minutes because I am getting indications to wind up.
Good afternoon, everyone. I would like to thank everyone for giving me the opportunity here. And as Sir asked me, like my age right now is 25, and I would specifically like to focus on space warfare. Like we have talked about the commercials, we have seen what are the threats and advantages majorly, but being myself, I grew up watching a lot of sci-fi, playing a lot of sci-fi games, and Star Wars or like Star Trek gave us a very specific description of space warfare. But when we think about it, like space warfare, what today is not exactly similar to that, but it is very real. I would like all of you to think of a premise. Imagine there are thousands of people who have the control over specific celestial bodies, solar systems, or even a space station, so to say. You have the power to mine or make your space assets, and there are no other rules. And what kind of chaos it can create is unprecedented. And this is not just a hypothesis. There is an online game which is based on this premise, which also have a lot of research papers published on it to show what sort of trajectory the human course will take if this becomes true. Now, what those theses say or what those research papers say the trajectory is like very similar. It has like uncanny similarity to what's happening to geopolitics today. How, like as Sir said, how space is becoming the fourth frontier of warfare, and how the need of assets is becoming more and more important to have a space domination is very similar to what they said. Now, we have seen a lot of advantages of space warfare that all have told, like from comms to like anti-satellites and everything that's coming up. But space warfare is not exactly something new. The first evidence or the first instance of space warfare that we have seen was during the Gulf War. We don't really think of it as space warfare, but the communications or the SATCOM technology that came that time made like Predators and Hawk drones capable of what they did. And the latest instance we can think of is like what's happening in Ukraine and how the Starlink has enabled them to do what they're doing. This, while sounds like all good, the threats that bring, how all of them have said, is very real. And like those threats are like they started with very conceptual thoughts. One of the first space weapons that was there was thought called rods from God. They were nothing but like huge tungsten rods thought to be dropped from space, and their kinetic energy would just devastate stuff from impact. Though today we have like space treaties which calls for non-weaponization of space, but like we are actually very closely scratching the borders. The closest thing that we have as a space weapon we can call off are like ballistic missiles, hypersonic vehicles, and they are quite lethal, as of to say. Like the lethality goes up as we go from like ballistic missiles to cruise missiles, and finally when we talk about glide vehicles especially, they are a very imminent threat, because as the trajectory goes higher and higher, we have a predictable ballistic course, and a lot of our interceptors today can predict where it's gonna be in a couple of seconds and launch our own interceptors to destroy it. But hypersonic glide vehicles can maneuver as low as like 30 kilometers, where like tracking them due to the curvature of Earth becomes very difficult, and by the time you know it is there, it's very close to you, it's super fast, and they can maneuver through the atmosphere, so it almost becomes impossible to hit. So this today brings us a need for defense of this, and a lot of the studies and thoughts of today's have been on that a single technology coming up may not be able to defend us against that. It's part of mesh intelligence. So a lot of technologies working together, from satcoms to missiles to forward-based radar systems, everything can contribute towards it. Now, when we talk about defense, one of the main factors is like, why are defense assets not being deployed forward? Like, they are not attritable. We need to make them attritable. What does it mean? We need to lower the cost. We need to improve the sustainability of it so that we can trade them. And a lot of the warfares today, how it's approaching is we are seeing a lot of deterrence. So standoff war is becoming more and more prominent today. We are waiting to see what the other person is going to do. What's the other side going to do, so that how can we counter it? And that brings us to a point where like arms race is more and more into proliferation. So talking about how today's technology can like be used as a future emergence. And so I like the one thing like Manoj sir said here is like the end application of whatever we are building needs to be very closely studied before we start onto a technology. A lot of the technologies that we have today didn't start as it was intended to be. And aerospace domain is such a sector where I believe like the technical downstream application has been huge. Like from common objects like air filter to shoe insoles that we use in everyday life today came down from like NASA's innovations for a spacesuit. So all of this tie down to together when we are coming to like decide on a technology or how we should think of something to develop for future. As Somnar sir pointed out in the morning, like a civil and a strategic value. Both, if a technology or a product can satisfy, it's of utmost usefulness. And as a spacefaring nation, and how we are trying to become like one of the space supremacy in the world, like we should be looking for like unmatched defense, and as for to stay like even achieve an unfair strategic advantage. That's all I would like to say.
Thank you, Nirvik. I think you have beautifully explained the future space wars, including hypersonic warfare. With that, since we have overshot time, now all that it leaves for me is to thank the panelists, particularly Lieutenant General Pannu and Mr. Sunil, Mr. Manoj Parmar, Ms. Sri Supriya, and Mr. Nirvik. Thank you all for sparing your time as well as sharing your thoughts, and me on my own behalf as well as on behalf of Synergia, I would like to extend a warm facilitation to all of you by thanking you. And can we do the honor? Yes.
Okay, so we'll just quickly do a round of small photo with everyone on the stage, and I'll have Sakshi represent a memento and a bag to each one of you. Thank you so much for your time.
Thank you, audience. Thank you, Sia.
Thank you so much, sir. I know everyone